What if Mars collides with Earth? Every planet in the solar system revolves around the Sun, as we all know, and they will continue to do so for a very long time. Ancient astronomers originally started to believe in some sort of harmony, a perfect balanced dance among the planets, known as the harmony of the spheres, when they first started to understand the motion of planets as seen from Earth. For instance, Copernicus believed that the planets orbit the Sun in circular fashion. But in Johannes Kepler's cosmology, the idea of sphere harmony came to play a major role. Kepler proposes a dynamic model of round spheres in addition to Copernicus' static one. He changes the planets' orbits, which move across space at different speeds, into ellipses. Instead of assigning each planet a single sound, he gives it an interval instead, where the lowest note represents minimal velocity and the highest, maximum velocity. This flawless balance, this symphony of the spheres, seemed unchangeable. You wouldn't anticipate the solar system to have undergone much alteration if you were able to leave it and return after around 1,000,000 years. It is therefore extremely improbable that something disastrous occurs, but what if it did? What if, for instance, Mars collided with Earth? Learn what might occur, how it might happen, and the risks involved. Think about how we can shield the Earth from such destruction. Due to the fact that Mars and Earth are in two separate orbits around the Sun, the idea of them colliding at first may appear utterly absurd. The host of the video, Gabe Perez-Giz, asserts that Earth and Mars can also be impacted by the gravitational pull of other planets in the solar system. Those extra tugging are now minuscule. However, if everything comes together perfectly, they might have a significant cumulative influence over billions of years and disrupt their orbits. Scientists need to conduct a lot of simulations, accounting for a lot of physics, and taking into account specific limitations in order to determine what would happen and how. They chose to slightly disturb the harmony of the spheres in one of the simulations. They merely shifted Mercury outward by 1 meter. They then stood up and went to the kitchen to prepare some coffee. When they returned, the simulations over billions of years plainly demonstrated that in this scenario, Mercury's increased position caused the orbits of the other planets to elongate. This resulted in an expansion of Earth's orbit around the Sun, Venus, and Mars. After that, the researchers found that Earth's new trajectory will put it on a collision course with Mars in 4 billion years. This was both amazing and unsettling. This is why. The effects of Mars colliding with Earth would be catastrophic. The impact would result in extraordinary amounts of destruction. Massive earthquakes, tsunamis, earthquakes, and volcanic activity would all be produced around the world as a result of the collision's great force. As communities and cities are destroyed by powerful volcanic eruptions, tsunamis, and earthquakes, these calamities could result in a global catastrophe. Temperatures would rise sharply as a result of the firestorm of gas, dust, and debris engulfing the planet, which would also result in a change in the planet's climate and unusual weather patterns. The impact would release a large quantity of energy, killing thousands and displacing millions. There would be a global famine as crops, cattle, and other resources would be destroyed in the aftermath of the shock wave and ensuing release of energy. Infrastructure and vegetation on Earth would be destroyed. The consequences of such an incident would also have a long-term impact on humanity as we currently know it. It might take several generations for the world to return to normal after a laborious restoration. Furthermore, the radiation and elevated temperatures would harm the environment, and the extensive damages might possibly result in the extinction of some species. If you did manage to escape in a spacecraft, you would witness the vast remains of both planets being propelled into various orbits following the impact. Others would be launched outside the solar system, while some would strike other planets. Whatever remained would create a brand new asteroid belt that would encircle the Sun. Nothing would indicate that the Earth once supported intelligent life. And all of the people you know, including you and I, would be lost forever. Perhaps no intelligent alien life would ever be aware that humans existed in the universe at any point in its history. But what's really intriguing is that astronomers are essentially certain that a comparable impact occurred in the distant past. Our lovely satellite, the Moon, was also created. According to the so-called Big Impact theory, the Moon was created when the Earth collided with a smaller planet that was roughly the size of Mars. The Moon was created when the impact's leftover debris gathered in an orbit around Earth. This theory is supported by certain data. For instance, the rock sample from the Apollo mission revealed some striking chemical and isotopic similarities between the Earth and the Moon, indicating that they may have shared a common past. The proto-Earth and Theia, a planet roughly the size of Mars, are both included in the scenario. The giant impact hypothesis postulates a collision between these two bodies somewhere in Earth's very early history. Nearly all of Earth and Theia melted and reformed as one body during this violent impact, with a little portion of the new mass spinning off to produce the Moon as we know it. In an effort to find the closest match, scientists have experimented with modeling the hit, altering Theia's size to see what happens at various sizes and impact angles. Since Earth and Theia were in the same area when the solar system was developing, their initial compositions were essentially identical. The same composition of the two bodies, as suggested by the Apollo mission samples, would also be explained if the two bodies originated from the same location and were made of comparable materials to begin with. We can see the most accurate simulation ever created to replicate the pre- and post-impact circumstances of the giant impact scenario in this brand new NASA film. When debris from the Earth and a mass the size of Mars was propelled directly into orbit after the impact, the simulation suggests that the Moon may have formed in a matter of hours. The simulations employed in this study rank among the most in-depth of their kind and operate at the highest resolution of any simulation done to investigate the Moon's formation or other massive impacts. Maintaining the right balance of planets in their orbits around the Sun is crucial to avoiding the terrifying possibility of Mars colliding with Earth. The possibility of an impact is avoided if every planet is perfectly aligned and spaced sufficiently away. Keeping this equilibrium is necessary for the solar system to function happily, with each planet maintaining its proper orbit and moving in a predictable manner. Both the continued existence of life on Earth and the health of the solar system depend on the planets remaining in a perfect state of equilibrium. The continuation of life on Earth and the stability and security of the solar system will both be guaranteed by the precise planetary balance. The main issue with this is that despite their small size, gravitational forces are extremely sensitive to changes. Although we've already witnessed it in the instance of Mercury, engineers and dynamicists are also extremely familiar with it. In theory, if we are aware of a system's current state, we may forecast its past characteristics and its potential future behavior. But in actuality, we use computers and do certain simulations, so this is only true in theory. Moreover, computers are not flawless. There will always be some mistake in each computation you perform on a computer. Of course, the smaller the error, the better, but since our calculations can never be flawless, a minor inaccuracy could eventually spread over a very long period of time, like billions of years. A cataclysmic disaster would result over a period of billions of years even if Mercury were just relocated a fraction of a meter. The same phenomena occurs to man-made satellites orbiting the Earth. Engineers require correction maneuvers in order to maintain their satellites in the desired orbits around the Earth or its Lagrangian points. There are methods for it, but they are very challenging to put into practice. A lot of research is being done to make sure that these orbits are stable. In conclusion, the prospect of an Earth-Mars collision is a terrifying reality, but it is crucial to preserve the harmony of the spheres by keeping the planets in a perfect state of equilibrium in order to prevent this disaster. Additionally, humanity must safeguard our planet by making every effort to keep the planets in our solar system perfectly balanced. Both the stability of our solar system and the continuation of life on Earth will be improved as a result.